Hello and welcome. Today I'm going to talk about real-world AI search in action. My name is Arturo and I work at MongoDB. That's why you see the branding on my slide deck because I've presented these at multiple places already. So, you know that the world is different now, and we know the world is always changing, it's always evolving. But now I'm referring to how things are different, right? A couple of years ago, whenever I needed some information, answers, I will go to a search engine. Now it's mostly via ChatGPT or Claude. I consume this information. The same goes for software development. Today, I mostly code this way. I talk to Cloud Code and then together come up with solutions, and Claude is the one that actually types the code. I review it on Visual Studio, but this is what I mean by the world is changing. But in the end, what's going on is really just an extra layer of how we transform data. That's ultimately what we have some source data, we apply informations to them, and then we have transformed data. Okay, it can mean multiple things. Can be like we have text or some data in a database, and then we transform it, and then we render it to a screen as a report or something like that. And the way AI works, the way LLMs work, is not too different. I think it's just a different way to transform data. The way we now write code, it's just a different way to talk to computers. So yeah, that's like the core. At the core of how LLMs work is something called embeddings. We're going to talk about it, but yeah, it sounds scary, but it's really not like that. So if we say that AI and LLMs are smart and are like breaking all these benchmarks, why sometimes we get wrong answers? Why sometimes we get something that's what we call hallucination? Well, AIs are not gods, are not super humans. They have limitations as we have as well. So for those limitations, we need to tackle them and find ways to improve the responses that an LLM will give us, but also give the the users of our developed software. Okay, so what are we doing today? Let's say that I have, or not say, I have a repository. I'll put the links in the description, where I've added all the notes and books and papers that I've been reading throughout the years related to AI. So what I want to create is a chatbot that can recommend materials to someone that wants to learn about AI. Now you might be wondering, well, I can ask ChatGPT for this, and yeah, but ChatGPT was trained on either data that we don't know the source, or it's going to use a certain data and bring it from, I don't know, Wikipedia, Amazon, or someplace. What I want is to have this chatbot to use my notes, the things that I found relevant. For this, we're going to build something like this. So let's say I want to learn the basics of AI. And then the chatbot is going to recommend a book from the list of books that I've read, etc. So in this case, we have narrowed down the scope of what the AI can respond, right? Because otherwise it might ask something like, oh, I recommend you to go and take this course and sign up for a university program or something. In this case, I want it to just respond based on my knowledge or knowledge that I have stored somewhere. Okay, so let's continue. And this process, this thing, it's called usually RAG, Retrieval-Augmented Generation. It's a fancy way to say we have an LLM, we want to extend its providing up-to-date information or domain-specific information that was not part of the training data. So if you just something to Claude, you will get responses, and I think good responses. But if you wanted to respond questions based on something that's only in your internal documentation for your company, that are not publicly available, or were not part of their training, or are not somewhere on the internet, then you need to feed them into the LLM. There are of course multiple ways of doing this, but we're going to go with what I think is the easiest path to implement something like RAG, without using many frameworks, etc. But I think it's valuable to have the intuition on what we need at the very basic to start building apps that are powered, or games or whatever, that are powered by LLMs. Okay, so this is a high level overview of what we need. We need data. We need to bring in our data from our PDFs, documents, databases, etc. We have to store the data. If we already have them in a database, then we can skip the first step. Then we need to chunk this data. We need to do something to make sure that the LLM is not overwhelmed by a lot of information. And we need to generate embeddings. This is a way to tell our database how to search for similar content to what the user is asking. And then we perform a search, and finally we provide our response. This is in a nutshell how this thing works. If you're using some framework or library or service, it might have the same, but more advanced or different names. But this is in a nutshell how I see this process. Okay, first step: ingesting the data. I told you I have a repository with a bunch of recommendations for books, papers, videos, tutorials, etc. That's what we're using as our data source. Okay, so if this was a PDF with my notes, etc., then I will need to get the PDF, parse the information, and store them in a database. Okay, so I'm using MongoDB, of course. I honestly love it. I think it's the path to build these apps that feels more natural, but you can achieve kind of the same with other databases. I don't know how, but that's why I'm sharing the process with Mongo. So I will create a collection in Mongo, which I will store my books with an ID, the title, the author, which is not me, the author of the book or the resource, my review. This is my note, and then a link to where to purchase the video. So the resource, the book, etc. This is how it will look. One example of a book already in Mongo, right? We have the ID generated by Mongo, the title, the author, my review, my note, and the link. That's what we have right now. Now we have to store that data, as I said. For storing the data, again, I'm using Mongo as a database, because I can store the information of the book, I can store the information of where to purchase, etc. But also I can store these embeddings that we'll see in a bit. Also, as we're iterating, as we're choosing models, LLMs to interact with our data, we need to have the flexibility of mix and matching, because there's yet not unique way on how to get the best result. To try and see if this model, this LLM and this embedding model works, and if not, maybe you need to change things. So you need a database that or a storage system that allows you that flexibility. And this comes with the Mongo's document model. So we're going to use Python, and you need to install PyMongo. Why MongoDB? Well, the document model, this flexibility that you get once you say, okay, this is the right data structure that I want, the schema that I want, then you can, of course, enforce the rules for the schema, but I need the flexibility right now. It comes with vector search integrated. So you'll see why this is important, but you don't need a separate database to store vectors and to search and perform operations on those vectors. There's a driver for Python, but there's also a driver for like 20 other programming languages. So you can achieve these in any platform that you are working on. Okay, so how do we store our data in Mongo? I'm not going to go through the details. I want you to understand that in this case, I'm creating a connection. I'm creating connecting to it. I will create a collection for my books, and then I will append the books that I have in my repository. This is how it looks. Atlas, which is the cloud-hosted version of MongoDB, it's the same. So just want you to know that there's another option if you don't want to host this locally, etc. You can just use MongoDB Atlas. And this is the book document that is already stored in there. One thing that I want us to pay attention is the review. In this case, it's not too long, but what if one book, I took a lot of notes and I have 10 pages of notes or something like that. Then probably when we feed that to the LLM, or when we're trying to search through my notes, what is more relevant to what the user wants, the review might be too long. So the next step is chunking the data. And in this case, I think it's fine if I had like a lot of information. I could fill the entire repo into the LLM context window and it will work. But what if you have, let's say, an internal manual of how your company operates or something like that, and you have literally hundreds of pages in PDFs, then that becomes even just for searching, right? Like the LLM, even if it can fit the entire PDF, and just considering there's one, but maybe you have hundreds of these files, you feed the entire thing into the context window, it will struggle finding like what's more relevant, etc. It's going to take more processing and it's going to be more expensive because you'll be spending more tokens. So you can chunk that information instead. How? There are multiple approaches. The basic ones are like a sentence based, so each sentence is a separate chunk that we will perform the embedding in. So just keep in mind that this is my paragraph or my information, and I'm going to chunk it in pieces based on sentences. There's another strategy that is fixed length, so every 100 characters we create a chunk, and we might get some cut out sentences, which is not the end of the world. You can actually, and this is something I've seen in practice, and I think it works really well. You have the fixed length chunking, but with some overlap. So whenever you search for something, you know that, the search returned me this chunk, this piece of information, but also there's something missing in here and might overlap with something else. So this overlap can give some meaning to what we're trying to search on. Hope it makes sense. You can always ask questions on or Twitter if something is not clear. So now with those chunks, we need to generate the embeddings. This is a very interesting process. It sounds like out of this world, but it's pretty simple. It's essentially just a function that transforms data into a vector or a list of numbers that hold some semantic value, some meaning value. So for example, in this case, this is just an example to create the intuition. Let's say we have a triangle, a square, and a circle, and we generate an embedding on them, and we get those values, those vectors of 3 floats. If we plot that into 3D space, we might end up having the triangle here, this circle here, and the square over here in 3D space, right? Imagine you want to add or compare what the cube, a new shape, is like, right? Like what shape in our current list, it's closer to the I want to compare it to. So you perform an embedding function into the cube, and it will give you another vector, and will be used to compare the distance between, or not the distance, sorry, the similarity between this object and the ones that we have already created. And depending on the embedding model, it might be like, the cube will end up closer or more similar to the square, maybe to the circle. So that's the idea, right? In just geometrically or by sight, we think, okay, it's going to end up closer to the square because these are similar shapes just in 3D. But when we talk about text, it's not as straightforward. It's not as straightforward to know, like, if I'm talking about databases and then I want to see in my notes what book recommends me databases. Maybe I don't have one, but maybe there's something that talk about data structures and storing stuff. Then we can see that, while it's not necessarily a synonym, might be related to that more than a note that I take about like philosophy and story of AI development. So that's the embeddings. Okay, so we're going to use VoyageAI embedding models, but you can use other embedding models. You just need to be careful that you use the same always for generating the embedding, and then when you perform the retrieval or the vector search, you generate an embedding model. Otherwise, the results will be different and it won't work. So same, we install the VoyageAI API. Why using these models? Well, again, you can use any, just use the same for generation and retrieving. And Mongo acquired VoyageAI last year, I think, or this year. And the results from those embedding models are great. I like is a couple of things. One is that Voyage has specialized models for things like legal tasks and health tasks. And also there's a new model that is documented. So it's not only you're performing the semantic application on your sentence or your chunk, but also aware of what the document is talking about. Okay, so we generate the embeddings just calling an API and with our string, in this case, the review, that's what we're using. And we generate the embedding and then we get it back. Since we're using MongoDB and the model, I don't need to make any changes to the database. I just need to insert the new field as a vector field into each of the documents. That's it. No need to make any other change. And yeah, so that's the step. Now we need to perform the semantic search. What we're going to perform against? Well, when the user types their query, their question, like, I want to learn the basics of AI, I'm a doctor or whatever, we will take the string, that input, we're going to generate an embedding, again, converting that to the vector, and we're going to query our database for something that's similar in meaning. So how do we perform this using vector search? This is included in MongoDB. It's part of the aggregation pipeline, which is very powerful. So yeah, this is the pipeline that we are generating. This is something you do just essentially once. But yeah, you can see here that I have this index, the query vector, this is the string, the question of the user, and how candidates I want to test against. A small number, and then how many I want to return, and this is the return data that I will get from the database. So I perform the search, and this is how it looks in Atlas. So that definition of the vector index looks like this. This is how it looks in JSON format. But things important to remember here is that you need to check in with your embedding model provider how many dimensions that model generates, because they need to be the same. And you have to select the similarity algorithm, and well, in this case, it's going to be an index of type vector. That's it. Now we need to provide a response. Okay, so we will be using GPT, but you can use any LLM. And here again it's a kind of a matter of understanding the model's strengths, costs, etc., to choose the right model, and then do some testing to see what is providing you better answers, more accurate answers. The embedding model used is very important, but also how your model, your LLM, interprets the data that you get. So we're going to use OpenAI. Essentially, it's another API call. You need to say, well, in this case, see that we're initializing it, and then we're going to get the results from the database from the previous step. And then what's key here is the prompt. The prompt, as you might know at this point, is kind of like the instructions that you want to use when you're them to do something. It's not just the last instruction of I want to achieve this, but also providing context of what the LLM should be aware of when providing the answer, right? So in this case, we are providing a response. I'm starting here the context string, and the context will include all the books and their notes that the vector search returned. So after the user typed the question, we searched on the database for reviews or books that are relevant to what the user wants. We feed that into the context, and then we continue telling the LLM, you are an AI recommendation system. This is what you do. This is the type of responses that you should give to your user, and these are the books that you have to recommend. Then at the end we say like how you want the response to be done, and it says in this case like recommend only from the list above. Don't recommend anything that is not in that list, etc. And this is something called some people say prompt engineering, context engineering. I don't know what it is, but you need to also be careful and keep track of how are more useful when you're using one model versus the other, and there are tools there to evaluate this. But so once we have the full prompt with the context, we simply tell GPT, like this is what I want, and then it will return us the response. There's this messaging queuing system that GPT uses. Other LLMs might work bit different, but essentially it's kind of like the chat user LLM type of format where the user wants something, the LLM responds something, etc. And then we will return the message that GPT responded. Doesn't need to go to a third-party server. It can be, the inference can run locally on your machine, but probably you will have less powerful models if you're running it in a regular laptop, for instance. But if you're interested in that, or you're still evaluating, there's something called Olama that allows you to download models, open models, and run them locally, and you can use them just to that set of, in this case, OpenAI's. Okay, so that's it. I hope it's been useful, interesting for you. But before you go, people ask if RAG is dead. I don't know. Maybe it's evolving into something with a different name, but the way I see things is not going to change a lot in the near future, because even if the context windows where you can feed all your data, it's going to be very expensive to do it that way. So that's one thing. And in this case, I didn't talk about it, but since we're storing this in Mongo in a database, I can do some hybrid search, not only asking for like books with similar meaning, but I could say something like, give me books published by this what's it called, this publisher, or that were released in this year. In that case, it's not really about any AI stuff. It's just regular querying a database, and I think that's powerful and allows you to kind of reuse the knowledge that you already have and give it less to the LLM to kind of guess what to do with data, right? So I don't think it's that. Again, name might change, but I've seen most companies and people trying to do one sort of rack or another. What optimization looks like? Well, it really depends to you. There are patterns, there are some frameworks, some ideas out there, but ultimately it depends on how accurate you need the response to be, how much budget you have to spend on in this case we're not doing training, but on inference, what embedding model works for you, constraints on how long it should take to give a response, etc. So really it's up to you. And in general, like the performance or optimization for software apply the same here. It's just, I think, more of a user experience and latency type of thing, right? If your answer is pretty accurate but takes the LLM 5 minutes to give it to the user, then maybe you need to optimize that. One thing, data is not always structured and complete, and this is something that data scientists have been dealing with for many years, which is like, okay, yeah, you have all your documentation in PDFs, but one PDF has one font and no images, and that's great. The other one is just images, so you don't know how really what you're getting. And the fact that we're using a database that's using the document model, I think it's powerful right now to get started at least. And lastly, Mongo has this Gen AI showcase with a lot of samples and projects that you can use, and Jupyter notebooks that you can use to get started, and some of them even to just to learn, etc. So also the repository with the books and resources I've been using to learn this. I keep doing it. If you have recommendations, feel free to send them to me. And thank you so much for your attention. I hope this was useful. And yeah, if there's any feedback, any ideas, anything that you think can improve and can help all other people learn and get into this new paradigm of building software and new paradigm of how we interact with computers, I'm always open to hear about ideas. So thank you so much.